So in this PowerPoint, please make sure that you have printed out section 10.5 from the portal so that you can take notes as we go through this material. We are going to be learning how to graph all 6 trig functions: sine, cosine, tangent, cotangent, secant, and cosecant. And so as we work on this, we're going to attempt to use our unit circle to fill in some of the tables that I have marked throughout the PowerPoint, and we are going to be focusing on the radian measure as opposed to the degree measure that you would rather see. And so I am not converting from radians to degrees, but I'm trying to use my unit circle to give me the value of sine at each of these radian measurements. So from my unit circle, I'm trying to create ordered pairs. At 0 degrees, the sine, the y value, is, and then we need to fill in this chart. So that's how I'm trying to think of this. So at 0, sine is 0. At pi over 2, sine is 1. At pi, sine goes back to 0. At 3 pi over 2, sine goes down to -1. And then at 2 pi, we go back to 0. And so these have already been nicely graphed for us over here. And what I found when I plot these, there's a whole bunch more that would go into this using most of our unit circle there. But these are going to be called the critical points and we are going to examine them in great detail in this section 10.5 as we start shifting our graph up, down, left, and right. So let's see what else. This is one cycle from 0 to 2 pi, and most of the time I'm going to ask you to graph one cycle of the given trig function. Now, this word periodic here means that our graph repeats over and over again. So we have one period, it goes from 0 to 2 pi, that gives us the complete cycle, so that is one cycle. I think I also mentioned. But the graph just doesn't stop at 0 or at 2 pi. It continues, and it makes the same shape repeatedly. So the graph starts all over again here, making the exact same shape that it did right here. And back here, let's see, I think this is -2 pi. That's what it's trying to say. So at negative pi, we have the exact same start of the graph that we did at 0, and this lovely wave just goes on and on and on. So if I were trying to figure out the domain of the sine, I can put any value in, any of my x values. So I'm going from -infinity to infinity for my domain. But for my range on my y-axis, like down here and up here, I've got absolutely nothing. So my values are restricted between -1 and 1. The cosine graph means that I'm going to be looking at the x value from my unit circle. So I'm going to try to fill in my chart over here to make ordered pairs, again using the radians as opposed to the degrees that you would rather see. So I'm looking at my nicely filled out unit circle, and I know that at 0 radians, cosine is 1, pi over 2, we're at 0, At pi, we're at -1. At 3 pi over 2, we're at 0. And at 2 pi, we're back to 1. So again, these are my critical points. And I start at 1 for cosine, go down to -1, back to 0, and up to +1. And so again, from 0 to 2 pi, I have one cycle, or one period, for cosine. And the cosine graph, if we look at it all along the x-axis here, with it repeating over and over again, it looks an awful lot like the sine graph. The only difference is that it's starting on up here at 1. So basically it's the sine graph but shifted, and we just have to be sure which one starts in the proper place. My domain again is from -infinity to infinity, because every value on the x-axis there gives me a part of my graph. And my range, I've got nothing down here and nothing up here, so I am going from -1 to 1. Now, with tangent, we know from our trig identities that tangent is sine over cosine, and if cosine is down in our denominator, we are going to have a problem every time that cosine is 0, which certainly happens. So let's see when we can take care of this. I have my values from sine and cosine between values of 0 to pi over 4. Those are no problem coming up with them off of our unit circle. And then I went the other direction, going down to get my negative values. So at -pi over 2, I am dividing by cosine, and that has a 0, so this is going to give me an undefined situation. Then at -pi over 4, I have -square root of 2 over 2 divided by square root of 2 over 2, and that sounds like -1. Then at 0, I have 0 divided by 1, sounds like 0. And then at pi over 4, I have 1. And then I have 1 divided by 0, which also sounds like undefined. Okay, so undefined, -1, 0, 1, undefined. I'm just cleaning up my work. So I'm going to try to take this table of values that I have over here and plot it to see if I can come up with something. And I don't know how successful I'm going to be with that. So let's see what happens. So this is looking at cotangent, and cotangent has sine in the denominator. And so this is going to give me an undefined every time that I am getting 0 from sine being 0. So I have a similar table set up here to give me cotangent. This time I need to keep cosine in the numerator. So like here I'm starting at 0, I have 1 divided by 0, and that is undefined. The next one, I need to divide by the square root of 2 over 2, well, that's 1. Then I have 0 divided by 1, 0, and then I have divided by square root of 2 over 2, well, that's -1, and now I'm dividing by 0 again, so that's undefined. So let's see, undefined, +1, sorry, not -1, 0, -1, undefined. Okay. Well now, someone connected a whole bunch of dots for me here because I didn't really have all of this. I knew that at 0, I was at 0. I knew that at pi over 4, I was at 1. I knew that at negative pi over 4, I was at negative 1. And I knew that at pi over 2 and negative pi over 2, I was undefined, which is where I will put in these. Remember them? Called asymptotes. Anytime we were undefined, we had an asymptote. So how did I go from an asymptote and a couple points to this graph? I am going to scribble out so we can't see all of this. We are truly focusing on just this part in the middle. Well, this would be where plugging in other values, like where we were at pi over 3, and then maybe plugging in something a little closer, because at pi over 2 we were already undefined. So I need something maybe in here, maybe in here, to help me get an idea of what this graph does, to know that we're going off. An asymptote tells me I'm headed towards infinity or negative infinity. It's a guide. Then the how do I know that my period is pi instead of 2 pi? That's an excellent question. Because my graph here has the asymptotes, it's going from negative pi over 2 to positive pi over 2. This length in here, maybe I'll put that in another color, from here to here, that distance is pi. And so that graph starts to repeat itself every pi units, and that's telling us our period is pi. Now, how do I write the domain and the range? Well, the range isn't that hard to see, that I'm going, down all the way to the bottom and up all the way to the top, so my range is from negative infinity to infinity. But I have these asymptotes where I am undefined, and that's a problem. It can't fit into the domain, so I need to erase a little. Maybe I can erase, maybe I can't. Oops, nope. So let's see. Nope, can't erase. All right. At every pi over 2, I have a problem. But it's not just a pi over 2. It's every single pi over 2. So I need to go positive. Those would be adding every single pi. And I need to go negative, subtracting off every single pi, so that I can get all the vertical asymptotes that are included in this graph. Now my cotangent graph is similar. I have problems not at infinity or negative infinity. Those are the places where it is undefined. And where it is undefined, I have a vertical asymptote. And at pi over 4, there's there, and there, and there. So my cotangent graph is similar to my tangent in that I have vertical asymptotes and I have this kind of sweeping curve that repeats with a period that is pi units wide. So my range, again, goes from negative infinity to infinity. And my domain, again, has problems because I have vertical asymptotes that occur every pi. And I'm starting at 0, so I have x cannot equal pi every and it's not just at pi, it's at every integer of pi. So that gets all my positives and all my negatives taken care of. Then there's my secants and cosecants. So let's see. Cosecant here, cosecant goes along with sine. So in this graph, the sine graph is drawn, and every place that the sine graph crosses the x-axis, we have an undefined situation. And where it's undefined, that means I have a vertical asymptote. So now, every place that we have our vertical asymptotes, we are going to have, including there at 0. There we go. We're also going to use our sine graph to help us create the graph for cosecant, because here in the sine graph, where the sine graph goes up at 1, that is going to be the bottom of the graph for cosecant. And so we're using this and our asymptotes as our guideline. Then where our sine graph came down, that is the top, and our asymptotes as guidelines for cosecant. So hopefully I did that well enough you can actually see where cosecant is. Here we go, and here we go, because everything was in red. And we have one period, since cosecant goes with sine. The period of sine is 2 pi. The period of cosecant is 2 pi. When I'm talking about the domain of cosecant, I have an issue every place that we had a vertical asymptote. So I have vertical asymptotes every place I was at a pi. So I need to indicate those, that at pi, x cannot equal pi, and k is an integer. For my range, I have a lot down here in the negatives and up in the positives, but I have nothing in my graph between 1 and -1. The part between 1 and -1 was my sine graph that I was using as a guide, but it's not part of my cosecant graph. So I have from negative infinity to -1, and from 1 to infinity. Okay, and secant and cosine are going to be used in the exact same way to help me get the graphs done. I'm going to use sine. Every place that my sine graph crosses the x-axis, I'm going to have a vertical asymptote, and that takes place at every pi over 2. So that's going to be at pi over 2 times k. And then every place that my sine graph goes up, my secant graph is using that as the bottom, and my asymptotes to go up, where it goes down, then I can make my asymptotes and the highest spot of the graph. The period of cosine is 2 pi, so the period of secant is 2 pi. My range, again, I have a lot of my graph below -1 and above 1, so I'm going from -infinity to -1 and from 1 to infinity. So this table here is trying to it's trying to summarize all of the characteristics of our 6 trig functions to help us keep in mind which graphs go together. So like the little triangle up here, sine is opposite over hypotenuse. Our period is 2 pi. Our domain is all real numbers, so from -infinity to infinity. Our range is from -1 to 1. And our graph, let's see, sine, I think that's even. Let me double check. Nope, I guessed wrong. The sine graph is odd. So when it's reflected about the even is when it's reflected about the x-axis. Odd is reflected about the y-axis? No, about the origin. There we go. Okay, now cosecant is hypotenuse over opposite. Period is 2 pi. The domain is not -infinity to infinity because we have problems at every place sine is 0. So x cannot equal pi k. The range goes from -infinity to -1, union 1 to infinity. And this is odd. I wonder if it's a coincidence that sine is odd and cosecant is odd. Let's see about cosine. Cosine is adjacent over hypotenuse. Period is 2 pi. Domain is -infinity to infinity. Range is -1 to 1. It is even. Secant is hypotenuse over adjacent. Period is 2 pi. However, x cannot equal every pi over 2 k. The range goes from -infinity to -1, and then 1 to infinity. And the secant is even. Okay, and the rest of this is for you to fill out.